Welcome to EDU World Space.
Problem 3.89. In this problem, there are three forces are acting on the system, and we have to replace these three forces by a single equivalent force couple system at point B. So for the calculation of equivalent force, we can observe one thing, that this two forces, 20 pound forces, are anti-parallel to each other and are separated by some distance. So these vectors will cancel out each other and they will have no effect on equivalent forces. So the only effect on equivalent force will be because of this 48 pound force. So equivalent force F will be 48 pound. Now talking about its direction, so from horizontal, let's say it is making an angle theta. So for the calculation of this theta, we can do some geometric interpretation here, that we can extend this ABC line in this direction. So this ABC line and this direction will be perpendicular to each other. So this angle is 55 degree. So this angle will be 35 degree. And if we draw a horizontal line from point C, so in the problem it is given that this is making an angle 30 degree. This is mentioned in problem. So this angle will also be 30 degree. So 48 pound force is making an total angle 65 degree with horizontal. So theta here comes out to be 65 degree. So this was the equivalent force acting at point B. Now for the calculation of moment, so there will be two moments. One moment will be caused by these two anti-parallel forces. So let's say that moment caused by these anti-parallel forces is m1. So, and considering the anti-clockwise direction to be positive, so these are causing a clockwise couple. So first of all, their sign will be negative. Now talking about the magnitude, we have two options. Either we can resolve these forces into its perpendicular component, or we can draw a perpendicular line between these two line of actions. So let's draw a perpendicular line between these two line of action of the force. So if we draw a perpendicular from this line, let's say this is the perpendicular and this is M. So the length of CM will be, if this angle is, let's say if this angle comes out to be alpha, so it will be 70 sine alpha. So CM will be 70 sine alpha. So we need to find the value of alpha here. So it can be found by using some geometry. Since this entire line is collinear, so this entire angle will be 180 degree. This angle is already known 20 degree, and this is perpendicular line. So this is causing 90 plus 20, 110 degree. So alpha will be 180 minus 110 degree, which comes out to be 70 degree. So perpendicular distance is known. So now we can directly write here the moment value, and it will be 20 pound multiplied by perpendicular distance between them, that is 70 sine 70 inch. And if we solve this, it comes out to be minus 478.828 pound inch. Now talking about the second moment, that is caused by this 48 pound force. So we can resolve this 48 pound force along this line ABC and perpendicular to the line ABC. So its component along the line ABC will be 48 sine 55, 48 sine 55, and its perpendicular component in this direction will be 48 cos 55, since this angle is 55 degree. So there will be no effect because of this 48 sine 55 48 sine 55 pound force, because its line of action is passing through the point B. So the only moment will be because of this 48 cos 55 pound force. So if we calculate M2, again considering the anti-clockwise direction to be positive, so it is causing an anti-clockwise couple, so this will be plus 48 cos 55 multiplied by perpendicular distance, that is 30 inches. So this comes out to be plus 825.95 counterclockwise, or it is positive, so it is counterclockwise. Now for the equivalent couple, we can write it as M1 plus M2. So M1 we have already calculated 478.828 and plus M2 is 825.95. So equivalent couple acting on the system comes out to be 347.122 pound inch. Since this is a positive quantity, it means that the equivalent couple is in counterclockwise direction. Now in second part, this was part A of the problem. Now in second part, they are asking to find the location of single force that will be present on this ABC line and its location from point B such that it will cause the same effect. So let's say if we observe one thing, that here moment is counterclockwise. So to replace this system of forces by a single equivalent force, so if we place our equivalent force on the side BC, it is going to cause an anti-clockwise. It is going to cause an anti-clockwise couple. And if we put the line, if we put it on line AB, it will cause a clockwise couple. So we need to put this equivalent force on line BC. So let's say that our equivalent force is at a distance A along the line from point B, and it is, let's say, acting here. So again this force is same as that of 48. So this was 48. We can draw it in much larger diagram, so it will be more easier to understand. So let's say this is B and this as is C. So equivalent force, let's say, is acting here and it is making an angle 55 degree with perpendicular line from BC. So let's say this point is P and this length BP is A. So this is 48. So 48 cos, the component of this 48 pound force along the line BC will be 48 sine 55, and perpendicular to the line BC will be 48 cos 55. So this 48 sine 55 will have no effect on its moment. So only the only effect will be because of 48 cos 55. So equating the moment, that is, this we have already calculated the equivalent moment, that was 347.122. This must be equals to 48 cos 55 multiplied by A. So A comes out to be 12.608 inches. So this is the answer for the second